So large terrains, let's take a look at this and look at how we can deal with this large amount of data. We all know where it's coming from, digital data. Point clouds and LiDAR. Now, what we need to consider is the point thinning. How we get down to a reasonable, usable surface and thin the data down, because what is a very dense surface may not make for a very usable surface, and it's got to be considering the use case that we're looking at and how we're going to use it. So for the extremely large, we might want to be considering the use of Descartes, especially geospatial level, and thinning it down and getting it down to a level that's more manageable and consumable in the design time environment. But this, what I like to call reducing terrain bloat, there are some factors associated with this. It's the pre-thinning that is required and how we can get to that. So we need to consider how we can reduce that down, minimize the area that we're working on, filter out information that we don't need, look at the different thinning methods that are available with tile and tin, because ultimately what we're trying to do is reduce it down to a reasonable level that's going to give us sufficient surface, quality of surface, that we can produce our design to.
Dealing with point clouds and large amounts of data, we utilize MicroStation's point cloud engine. So here I'm just going to attach 16 tiles into the current display, and at the moment it's utilizing the RGB display style, so we can kind of see, we can make out features in the point cloud, white lines, utilities, and so on and so forth. Now obviously if we wanted to utilize some of the extraction capability within Descartes, we could utilize the intensity, so it helps us in terms of picking out those linear features that we might want to extract, be it either dashed lines or solid white lines. But typically what we want to utilize, assuming we have the classifications available to us, are the classifications, because we can use these to help thin the data down. So once we've got the data in a classified format, we can identify an area of interest that we want to work on, and we have to consider the terrain size that we're going to produce and limitations of legacy file formats that we might want to work with. Obviously we can still tile just as we've always done in the legacy formats as well. So here I'm just going to use the classification and modify this mode to disable some of the information that I don't need to see, thin it down. I could create a new style to thin the data down, just get rid of the points that I don't need. So from the original 80 million, that's already thinned it down to about 30 million point cloud that I'm dealing with here, which is in a realistic sense still too much to deal with. So what we need to utilize now is the ability to actually control the areas based on a clipped zone. So if we have an area of interest that we want to work on, we can create a fenced area that we're going to work inside of to actually sort of look at and build a detailed terrain form. Do need to select that as the fence in the first instance. So pick the area I want to work on inside and accept. So now as we activate the point cloud, we can define a feature definition, and the recommendation here is always to use a boundary mode, and in this instance I'm just going to use a simple tin and a coarse tolerance. And now that's finished importing, we can clear the view and we are left with the civil terrain that we can actually work with. In this instance the point thinning has reduced it down quite heavily, so it is in a state where I am quite comfortable in terms of turning on triangles themselves.
So again, best practice when using point clouds, look at the thinning methods, look at the categories, try and fence the areas down and create graphics that you can go back and adjust and rework to deal with that. The key thing is dealing with terrain that can be passed back potentially to a legacy product. So really what you're looking at there is what is consumable in the legacy products of Geopack Inroads MX, and so that needs to be considered in terms of dealing with the terrain. So also think about creating multiple tiles and how you deal with the terrains in those legacy products, because ultimately you probably still will need to integrate at that level. So what I want to look at now, I've mentioned Descartes and some line extraction, and I just want to touch on that very briefly because it's becoming more and more common practice and requirement. And Descartes provides us with some advanced point cloud processing that deals with the extraction of civil objects that we may well need. And here what we have is an example utilizing Descartes. We're looking at a point cloud scan that includes overhead transmission lines. So we're using the intensity to adjust the display and adjust the representation so that we can actually see the lines that we want to trace. We can use the 3D line following tool to identify the trace line that we're going to pick on, give it a direction indicator, and it traces and runs down to the very end of the line based on that intensity. So what we can now see, we've extracted very quickly from giving it an indication of direction, a line string, a 3D line string that's a solid line representation. We could extrude down it if we needed to. We can do clash detection. We've got clearance checking and so on. And obviously, to a point cloud, you can measure distance anyway. But now we have something tangible and physical as a line graphic in the drawing. So I can very quickly go through and extract lots of lines. Here, another situation where we have white lining. Again, using the 3D line following tool, we can trace along and give it an indicator as regard to a solid white line and get it to trace down the segment of a point cloud that we want to track along. So it becomes a very easy way of extracting from that point cloud data the area of interest that we need. At the same time, we can do the same thing for dashed lines, specifying a gap that we want to jump over.